All right, and welcome to 3.4, where we're going to recap how to balance chemical reactions. So we're coming back to this after we did it in our first unit. We're going to look at it in a bit more detail and just make sure it's really solid in our heads how we need to balance a chemical reaction. So just a bit of a reminder, a chemical reaction is something that describes a chemical change. So there are two parts to a chemical reaction. We've got our first part with our reactants. These are the things that are reacting. We use an arrow to sort of represent the direction that things are going in, and we end up with our product, and these are the things that that reaction produces. So that's our general sort of structure of a chemical equation. Some terms to be familiar with. Alright, so we've got reactants, obviously what we begin our reaction with. So these are the chemicals you start with before the reaction. The ones that we produce, those are our products. And we've got a couple of other words here just to talk about the numbers that we might see. So those little lowercase numbers there, those are called subscript. And subscript are really important. The little numbers that you find in a molecule's how it's written, and they're there to tell you how many of a certain type of element are present. So for example, we have water here, and water is H2O, and that little 2 there, the little number is always attached to the letter in front of it, or whatever element comes right before it. So the 2 belongs with the hydrogen, and it tells us that there are 2 atoms of hydrogen present in that molecule. Oxygen doesn't have a number out of it, and so we know that must mean it's just one oxygen atom. So that's what the subscript does. The other number you might see is a big number out the front of a molecule, and this is called the coefficient. Down in our example here, we've got a 3 is our coefficient, and what it's telling us is that there is 3 of the thing that comes after it. So a coefficient shows us how many molecules there are of a particular chemical. So here our coefficient is 3, and then we've got H2O following it, so it means that there are 3 H2O molecules, or 3 water molecules. Now, this is an example reaction. This is balanced, so this is how water can get made. We've got our hydrogen gas plus oxygen gas, and they're reacting to form H2O. And you can see here, as our red oxygen molecule comes in, we have these 2 green hydrogen molecules come in, one pair attached to each oxygen, and the oxygen split apart, and we get a hydrogen where we have one oxygen with one red oxygen with 2 green hydrogen attached to it. Now, the reason this is important is we need to remember that we have to obey the law of conservation of mass. So in a chemical reaction, matter is neither created nor destroyed. In other words, the number and type of atoms going into a reaction must be the same number and type of reactions that come out. When an equation obeys the law of conservation of mass, then it is balanced, and this is what we want. We want our reactions to be balanced. We want to obey the law of conservation of mass. We don't want to try breaking the laws of the universe. So here's a couple of examples of what I'm talking about. We've got here our reactant side. You can see here we've got this is methane, CH4, this is oxygen, O2. These are our products. We've got CO2 here, and we've got H2O down here. But if you go through and count it up, you notice that you've actually got 4 green circles here, but you've only got 2 here. So that's a real problem, because what's happened to those other 2? Where have they gone? They can't just disappear like that. That violates the law of conservation of mass. So that needs to not happen. Underneath, you can see when we change those coefficients at the front and we change how much we have of each thing, then actually we are now starting to balance it out. And we end up with, you've got your 4 green here, and you also have 4 green on this side, which is good because we're obeying the law of conservation of mass now. So here are some rules for when you're balancing equations. First of all, matter cannot be created or destroyed. You can't have things completely disappear. You can't have them appear from nothing. You cannot mess with the subscripts. Those little numbers you do not touch. Do not touch the subscripts. You cannot do that. The reason for this is the subscripts are all about what's in that molecule and what that molecule actually is. When you start messing with subscripts, you start changing the molecule. For instance, we all know that water is H2O, but if you were to add an 2 at the end of that and you got H2O2, that is a completely different molecule. That is actually hydrogen peroxide, and it behaves in a completely different way. So you can't change the subscripts because you start talking about different things. Okay, so this means the only numbers that you can change are the coefficients. The only thing you can mess with are the numbers out the front. And the reason for that, the reason is that those are just telling you what quantity there is, how much is there of something. The other thing you need to realize is that those coefficients, they only go in the front of the chemical formulas. They never go in the middle of a formula. And I'm just bringing this up because people in the past have tried to change just part of a molecule and just want to have more oxygen or something like that. And so they put their number in the middle, and that's not where it goes, because that's trying to change what the molecule actually is, and you're not allowed to do that. You can just change how much you have of something. And that's what the whole point is. You're trying to get the ratios correct. Have I got the right amount of this compared to how much of that thing I should have in this equation? I've got 3 tips there for you to try and help you as you're doing this. First of all, try for the big molecules first. Those are the ones that have multiple elements in them. And the reason for this is when you go to change one of them, maybe just to change one type of thing, you'll end up changing others as well. And it's really annoying if that's one of the last things you're trying to do and everything else is balanced. You don't want to have everything else balanced. You go change one thing and it throws it all out. So we go for those big ones first, and anything that's what we might call a free element. So anything where it's just that one element in the molecule. It might be, just a single iron atom, or it might be an O2 molecule. Either way, they are just the one element, and if you change it, they're not going to have an impact on anything else. So save those free elements for last, because those are nice to do at the end, because they're basically the last finishing touches of balancing. If you've got a polyatomic ion appearing on both sides of the equation, it's usually okay to treat it as one unit. All right. Now, this is not a hard and fast rule. It's more some advice when it comes to dealing with these sorts of things. Now, there is no one particular way when it comes to balancing chemical equations. Some equations are harder to balance than others, and they might require a little bit of creativity when it comes to solving it, or a little bit of guts to, actually attempt, I'm going to change this and we're going to see what happens. And the reason I say that is sometimes the next step isn't obvious. And so you actually have to try it and to see if it goes right and see how it goes down the track. And if it doesn't work, that's okay. Come back, try again. So sometimes there is that bit of trial and error, and that requires a little bit of courage to do and a bit of creativity as well. So most reactions tend to have a pretty obvious next step, or at least a couple of ways you can go about doing it, and it won't be too difficult to approach them from either direction. So let's have a look at a couple of examples. Here we've got N2 plus H2 gives NH3. So the best way to go about doing this is write a table like this with your reactants and your products. Okay, we're going to put nitrogen in the first row and hydrogen in the second row. Then fill in your table with what is currently present. So on the reactant side, I have 2 nitrogen and I have 2 hydrogen. On my product side, in that NH3 molecule, I have 1 nitrogen and I have 3 hydrogen. If I go through and I go, okay, well, I need to change things. I need those nitrogens to be the same. I can put a 2 in front of the NH3. When I put that 2 in front of the NH3, it's on the product side, it's going to change how much nitrogen there is. And it's going to go, I've got 1 normally, but now I have 2 sets of 1. So 2 times 1 is 2. So I changed that in my table. But here's the thing, I put it in front of a molecule that had not just nitrogen, but hydrogen. So now I also need to change the hydrogen. And it's really important not to skip doing these, because occasionally this is where, if you're not able to solve a problem, this is where you've gone wrong. You've actually just changed part of what you needed to, and you didn't do the whole thing. And so now you're not looking at the wrong numbers. So we're going to change hydrogen. We've got 3 hydrogen normally, but we have 2 sets of that. So 2 times 3 is 6, and that's what we'll put in our table. So looking at our table, nitrogen's balanced, but hydrogen isn't. So we're going to turn to the reactant side. Remember, you can never take things away from that equation. You can only add more in. So we're not going to touch nitrogen. It's fine. We're just going to look at the reactant side, and we're going to look at hydrogen and go, well, what can we do to fix this? Now, we want to see, can we get that up to 6? Now, hydrogen, you have to remember, comes in pairs. It always comes as H2. So the question is there something I could have a certain number of how many H2 molecules do I need to have 6? Now, if you remember your basic maths, you should know that 3 times 2 is 6. So if I put a 3 out the front, then I'm going to actually have 6 hydrogen, and I can change that in my table as well. So there we go. That is balanced, and we would have N2 plus 3H2 goes to 2NH3. That is our balanced reaction. And this is what we're talking about, something like this. All right, example 2. Let's have a go at this one. That's KClO3. I know it might look like an I, but very rarely do you have Ci like that. It's most likely going to actually be a lowercase l that looks like a capital I because of the font that's being used. So that is KClO3. That goes to KCl plus O2. So let's go through our table again. It's a little bit bigger because we've got 3 elements this time. We've got K, Cl, and O. We're going to go through, we've got 1 potassium, we've got 1 chlorine, and we've got 3 oxygen on our reactant side. On our product side, we have 1 potassium, 1 chlorine, but only 2 oxygen. So we're going to have to go through and work this one out. So if we look at this, we can go, okay, well, potassium and chlorine are balanced, so I don't really want to touch them, and I can't change oxygen by 1 on the product side, so what am I going to do? So this is where you might need to get a little bit creative. Now you can go through and do this a couple of ways. I'll give you sort of a couple of tips. One, you can go through really slowly, and you can attempt to change things just sort of 1 molecule at a time, and that's going to take you a while. I can tell you now, if you change oxygen, instead of having 1 oxygen molecule you have 2, you're going to have to come back to that, and you're going to have to increase it again. You could look at the 3 and the 2 for oxygen and go, okay, well, maybe what's their lowest common multiple, or that would be 6. So I could go, okay, how do I get 6 and do it that way? Another option would be to actually go, okay, what do I need to have on in front of my oxygen to get this right? If I had 1.5, it would be fine, and something like that. And there is a technique where you can do that, and I'll go through it in a bit more detail, where you can sort of use an intermediate step to get what you want. We're going to use the lowest common multiple, so we're going to go, okay, I've got 3 oxygen on one side, 2 on the other. If I have 3 oxygen on my product side, that's going to give me 3 oxygen molecules, that's going to give me 6 oxygen atoms. That means I could come back and I could change my other side, my reactant side, to having 2 of those, and then I'd have 2 times 3 is 6, and so that would work as well. And so that's what we're actually going to do. So we're going to make that change. Now there's a number of things we're going to have to change. We're going to go through and change our reactants first of all. And so we've got 2, 2, and 6, and then our products are now 1, 1, and 6. So I'm thinking, okay, what do I do? Okay, so what do I need to do? Well, I need 1 more of both potassium and chlorine. So let's add another potassium chloride molecule. We'll put a 2 out the front there. And so now we've got 2 and 2, and we're balanced. And that's what this looks like. All right, what you could have done, I'll just jump backwards a little bit. If you didn't want to go with the lowest common multiple, you could go, okay, to get my oxygen to be balanced, I need to have 1.5 in front of that, because 1.5 times 2 would be 3. And that gives me 3 over here. But the problem is you're not allowed decimal numbers as your coefficient. So when something like this happens, if you're in this situation, what you can do, put your decimal in. This is your intermediate step. It doesn't stay this way at all. But you put it in as an intermediate, and then you go, okay, now I have a decimal there. I need to multiply through this whole thing by 2. And this is really handy in these sorts of situations. So if I multiplied all the coefficients by 2, for my first one, that's a 1. So 1 times 2 is 2. For my next one, for my potassium chloride, it's also got a 1, so 1 times 2 is 2. And over here for my my oxygen, where I have 1.5 times 2 would actually be 3. And so you can see, I can then go through and see what's happened with this. So if I go through my reactants, I would go, I've got 2K, okay, I've got 2Cl, and I've got 6 oxygen on that side. Okay, so that's my reactants. If I go then up to my products, I've got 2K, I've got 2Cl, and then I've got 3 times 2 is 6, so I need to revise that. So you can get to exactly the same answer through a slightly different method, and this is really reinforcing what I was saying before, but there's often multiple ways you can get to the correct answer. And that using that sort of half step is a really handy technique for a certain set of molecules, a certain set of reactions. I'm not going to tell you which ones, because you might come across them in a little bit, and I want you to be able to recognize them and work through it yourself. So speaking of working through reactions, I have a whole bunch here for you to do. So I want you to pause the video and go through these, and when you're done, you can come back and we're going to go through them together. So pause the video now. Alrighty, so how did you go with those? Did you get through them all? Well, we're going to go through them now so you can see how to work them out. We're actually going to go to a new slide for each one because otherwise we won't have space. So we're going to start off with C2H6O2 CO2H2O. Okay, the first things first, we're going to need our table. So I'm going to go reactants and products. And I've got C, H, and O, so I need 3 rows. C, H, and O. Alrighty, so let's go through and fill this in really quickly. Carbon, I've got 2. Hydrogen, I've got 6. Oxygen, I've got 2. Carbon, I've got 1. I've got 2 hydrogen, and I've got 3 oxygen. Alrighty, so oxygen is the only thing there that occurs by itself, so it's the one I'm going to leave probably for the end. All right, sometimes we try and do that and it just doesn't work out, but that's when we're going to try and do this. We're going to start with carbon. So I'm going to put a 2 in front of my CO2 because then that's going to give me 2 carbon on either side. But by having 2 carbon there, it's then affected my oxygen. So I've got 2 times 2 is 4, plus 1 over here is 5. Okay, so important to notice that sometimes elements occur in more than one molecule, particularly something like oxygen. Alrighty, hydrogen, let's have a look. So I've got 6 and 2. Well, I can fix this by putting a 3 out the front. If I put a 3 there, then I'm going to get 3 times 2 is 6. But again, this is having an impact on my lovely oxygen. So I've got 2 times 2 is 4, plus 3, because this is 3 times 1. So 4 plus 3 is 7. That's a bit annoying because on my reactant side, oxygen occurs in pairs. So how do I get that to work? Well, this is where what I was mentioning before about that half step comes in really handy. So what do I need to multiply 2 by to get 7? Well, I'd have to multiply it by 3.5. Okay, and that would give me 7. But even though this is balanced, there's a problem with my reaction. I am not allowed to have a 3.5 in front of something. So like I was saying earlier, this is where you need to go through and you multiply everything by 2. And when you do that, you end up with only whole numbers. So there's essentially a 1 out the front of my C2H6. So I'm going to make that a 2 at the front. All right. Then we're going to take that 3.5. All right, we're going to get rid of that. We're going to take that and we'll actually get rid of, oh, no, we won't do that right now. We're going to write in 3.5 times 2, that would be 7. Okay, and then we're going to get rid of our other ones as well. 2 times 2, get rid of that 3 is 2. Oh, 2 times 2 is 4. And the 3 that was here, 3 times 2 is 6. All right, so we can now go back through and see how that all works. So we've got on our reactant side, 2 times 2 for the carbon would be 4. It's really important, by the way, to go back through and check that it does actually work and that you've not done the wrong thing in getting to this point. Hydrogen would be 2 times 6 is 12. And then our oxygen is 2 times 7, which is 14. Okay, so we've got 4, 12, 14. Hopefully we get that on our product side. Carbon, 4 times 1 is 4. So that's good news. That works. Okay. Hydrogen, 6 times 2 is 12. So that also works. And finally, our oxygen, we've got 4 times 2, which is 8, plus 6. 8 plus 6 happens to be 14. There we go. So that's how we can balance that reaction. Alrighty, now we've got iron and oxygen reacting. So let's pop our table in. We're going to go reactants, products. We've only got 2 different elements, F, E, and O. So quickly filling this in, we've got 1, 2, 2, 3. So iron here is the one I'd leave for the absolute end because I can change it one at a time, and when I change it, it doesn't affect anything else. So we're going to leave iron to the end. We're going to do oxygen first. Now, this is another one where you can use a half step, or if you cast your mind back to earlier, we also use lowest common multiple. When we looked at this, we've got 2 and 3, you know, that's probably going to need to be 6. So what do I need to do in front of those things to get them to that number? So we're actually going to go that way this time. We're going to increase our O2. We're going to put a 3 in front. We're going to change that to 6. then we're going to go to our Fe2O3 and we're going to put a 2 in front. 2 times the 3 on the oxygen, that gives us 6. Now that also affects our iron, so 2 times 2 is 4. And remember I said on the reactant side you can change iron by itself and you can do it one at a time. So what times 1 is 4? Well, 4 times 1. So we're going to put 4 at the front. 4 times 1 is 4. And there we go. That is that reaction done. It should be 4Fe3O2 goes to 2Fe2O3. Alright, reaction 3. Na plus Cl2 goes to NaCl. Alright, P is our table. NaCl. We've got 1, 2, 1, 1. Alrighty, this one should be pretty easy. First things first, we need to make sure there's more chlorine on the product side, so let's pop a 2 out the front there. Then we can change that to 2. We're going to change our sodium as well, now we've got 2 there. And now we need to have 2 on the reactant side, we're going to put a 2 out the front. There you go, that one's all done. That one should have been pretty quick if you got up to this one. Alrighty, CH4 plus O2 goes to CO2 plus H2O. We've got reactants and products. Okay, we need 3 actually. Carbon, hydrogen, and oxygen. So 1, alright, 1, 4, 2, 1, 2, 3. Alrighty, let's go through and work this one out. So if you actually are looking at it, you'll notice that the hydrogen and the oxygen are out of whack, and they're out of whack in a ratio of, you've got 2 hydrogen and you need 1 more oxygen, but it's not the way round we want it to be. Unfortunately, we can't just whack a water on the far side and call it a day. So we're going to have to go through this a little bit more detail. So let's increase the amount of hydrogen we have on the product side first, because oxygen needs to be changed, but it's by itself, so we can leave it for the end. So hydrogen, we're going to go and put a 2 at the front. Now 2 times 2 is going to give us 4, so hydrogen is all fixed up. And we've got 2 oxygen in the carbon dioxide, and now we have 2 with the water, so 2 plus 2 is also 4. Now we can turn our attention to the oxygen on the reactant side, and we want to know what times 2 is going to give us 4. Well, 2 times 2 is going to give us 4, so we're going to put a 2 out the front, and now we have 4 oxygen. And so there we go, 1 carbon on each side, 4 hydrogen on each side, and 4 oxygen on each side, and we're done. Alright, second last one, lithium plus nitric acid goes to lithium nitrate and hydrogen gas. So reactants, products, and then we've got lithium, hydrogen, nitrogen, and oxygen. Alrighty, so lithium 1, hydrogen 1, nitrogen 1, oxygen 3. Lithium 1, nitrogen 1, oxygen 3, hydrogen 2. So unfortunately we've got an annoying little hydrogen that decided to be unbalanced, so we're going to go in and fix that up. I'm going to put a 2 in front of the HNO3 because we need to increase that hydrogen by 1. So 2 times 1 is going to give us 2. Unfortunately, this now means we have to mess with a few other things. So now we have 2 nitrogen and we have 6 oxygen. So that's a bit of a pain. Alrighty, so let's move to the next little bit. And we're going to go, okay, let's try and fix up nitrogen and oxygen. Now we're going to leave lithium alone because at the moment it's balanced, and if it wasn't, it also happens to occur by itself, and we can change it also one at a time, so it's nice and easy. So we're going to go hands away from lithium at the moment. Sorry, lithium on the reactant side, that is. We're going to look at the product side. We need to increase that nitrogen and oxygen by 1 and by 3 respectively, and the only way to do that is actually to put a 2 out the front of LiNO3. When we do that, we end up with 2 times 1 for the nitrogen, so we end up with 2 nitrogen, and 2 times 3, which is 6 for the oxygen. But unfortunately, we've now affected our lovely, or was balanced lithium, and so now we have 2 lithium. But remember I was saying we weren't going to touch that lithium on the reactant side because it was by itself and we could change it one at a time. Well, this is why we left it alone, because now we can go and put a 2 out the front of the lithium, nice and easy, and that becomes 2 lithium there. So there we have that one balanced. Alrighty, lucky last equation is Al plus O2 goes to Al2O3. So reactants and products, Al and O. Alrighty, so we've got 1 and 2, and then 2 and 3. So this one you can go through in a few different ways. You can do it the slow way, you can do it with the half steps, you can go lowest common multiple. How exactly you want to tackle it is up to you. Generally, I would probably try and leave aluminium for last, because you can change that without too much drama. For this one, I'm going to go and do the lowest common multiple with oxygen first of all. So I'm looking at oxygen. On one side it's 2, on the other side it's 3. That's kind of hinting to me that maybe this is going to end up being a 6 in the table. So I'm going to put a 3 in front of the O2 to make this 6, and then I'm going to put a 2 in front of the Al2O3 to make that 6. But when I put that second 2 in, that also affects my aluminium. There we go, had a bit of a glitch. So we're going to get rid of that too. And we've got 2 times 2 is 4. Now remember I said aluminium, leave it for last because you can change it one at a time. So now we can go to our aluminium, and I need 4 of them on my reactant side. So I'm going to put the 4 out the front, and 1 times 4 is 4. And there we go, that's how we can balance our lucky last one. Alrighty, well that brings us to the end of the PowerPoint, to our flip chart. I hope you got a lot out of that. Now, if you didn't understand anything, feel free to go back, rewatch it, speed it up, slow it down, pause it, go forwards, backwards, whatever you need to do to get this stuck in your head. And remember, you can always ask one of your teachers for help as well. Anyway, thank you for listening.